Hello everyone, welcome back to MindMatrix YouTube channel. I'm Sachin. So today I'll be starting with probability chapter, which is like quite important for GATE data science and DA exam, basically DA exam and GATE computer science. Okay, so from both the point of view, it is really important. Okay, so we'll be covering enough of the topics from that. If I talk about computer science, so it would be completed for sure. Okay, complete probability would be covered, but from data science point of view, I'll be showing the syllabus. So yeah, there I'll be telling you exactly what we'll be covering. Okay, so a brief intro about me. So I'm upcoming data scientist at Lois India Bangalore, and I'm right now pursuing M.Tech AI at IISc Bangalore, and the rest you can read. Okay, so let's begin with a topic of the day, that is probability. Okay, so the syllabus is over here mentioned. I have taken a snapshot over here proper. Okay, so you can see that not much difference apart from this statistic part. Okay, the statistic part is quite like bigger one which is present over here. Okay, basically it involves the tests as well over here. So these kind of over here, if I just mark it with red would be better. So yeah, this part. So it includes, I'm not talking about the cumulative distribution function that I'll be covering, conditional PDF I'll be covering, central limit theorem I'll be telling you that as well. Okay. The rest of the part, okay, I can give you the idea of all, but still it is all about the time, how much time we'll be having. But rest assured, we'll be covering the major probability portion for sure. Okay, up to this point, and some part like conditional PDF, because that is the part of this probability only. Okay, these are also the distributions from probability, but it's some other topic which is quite relevant to our statistic more. Okay, and hypothetical testing, hypothesis testing. Okay, and if I talk about the GATE computer science, so yeah, rest assured that would be completely covered. In fact, you'll be learning bit more only. And if you want to know, so yeah, wouldn't it be extra for us? The answer is no, because there are a number of terms which are not mentioned over here. One of the terms is like expectation, but it's written over here. Okay, and mutually exclusive events. Okay, what is independent event? Not written in over here, but those are important from computer science point of view as well. The questions were being asked. Okay, so we'll be covering all that. So that was all about the syllabus. A brief idea I have given that what we will be covering. Okay, so before moving on to the our topic, which is like probability, there is a small portion which is being mentioned that okay, counting. And just because while we will be solving a number of questions on probability, we will be required some basic permutation and combination as well. So I thought, okay, we can cover that as well. I won't be covering enough, like as in computer science we have combinatorics, so I won't be doing that. But yeah, simple counting techniques and some basic part of that I'll be covering for sure. So let's start with the first, few these are the basic terms. This is not, like I won't be ending it over here. So I'll be, further discussing permutation, combination, and distribution further. And this distribution doesn't mean probability distribution over here. It is simply distribution of objects I'm talking about. Okay. So let's talk about simple counting over here, and we'll be starting with the basic rules we are having over here, the addition rule and the multiplication rule. Okay, let's start with these only. So let's take an example, a direct example. Okay, so let's suppose there is going to be a big hackathon. Okay, there is a hackathon which is being organized. Okay, and let's suppose like I'm limiting up the number, that there are like 3 boys and 4 girls have participated. Okay, and it was told that only winner would be there. What did I say? Only one winner would be there. So what will you be telling me as an answer, that okay, what exactly is the answer for this? In how many ways there can be a winner? So it's very simple. If I just ignore the boy or girl, I know there are 7 candidates present. Yes or no? B1, B2, B3, and then we have G1, G2 up to G4. Okay. Basically, I could write G3 as well. Okay. So we have like 7 candidates over here. If I just completely ignore boy or girl, the question being asked was like how many ways I can have a winner, hackathon winner. So it's like 7 candidates are there. I need one winner. So there are 7 ways. Did I think much over there? The answer was no. point is, we, without even thinking much, used addition rule over here. What did we use? We used addition rule. How? Okay, see, one way was selecting this one as a winner. Other one was selecting this as winner. Selecting this, and further up to this point. Okay, so any one of these could be a winner. The thing was, only one can be there. So we have an option available. Okay, and out of these we have to take only one. So always remember, whenever we have a case, when we have a multiple option and we have to go with only one, there we will always be considering what? Addition. Okay, so what have you done over here? It was nothing but 1 plus 1 plus 1 up to like 7 times, and that was the answer. Okay, and if I slightly modify this question and say, okay, only one of the boy or a girl can win, again answer would remain same. The language have been changed over here. What did I say? Only one boy or a girl, sorry, either a boy or a girl can win. If I say like that, okay, then you'll be like, okay, so now again what is being mentioned is only one boy or a girl. That means again no two boy, two girl, and one boy or girl, like two people won't be winning over here again. So what would be happening? Only one winner would be there. So again the answer would remain same. They just confused you. So how was it over here now? So now you know, as they mentioned, one boy, either one boy or a girl. So for boy we had like, okay, we knew we had 4 choices. For girl, sorry, for boy we had 3 choices, 3, okay, and for girl we had 4 choices. Okay, so now if I talk about how we are coming up with 7 answers, so it was simple. Okay, that from boy one of the winner can be like, there are 3 ways. From girls one of the winner can be in 4 ways, and from among these boys and girls we need only one. So again 3 plus 4. So it was like a very simple, quite simple logic over here, and no need to complicate. Okay, let's move further. So if I tell you that, okay, the question was like that one boy and a girl would be winner. What did I mention? One boy and a girl would be winner. That means one of the boy from 3 boys and one of the girl from 4 girls would be coming up and they'll be winning. Total 2 candidates would be winning up. Okay, so that means if I talk about boy, how many choices do I have? Again 3 choices I had. If I talk about girls, how many choices do I have? I'm having 4 choices. Okay, but right now I need both of them. Whosoever among boys and whosoever among girls would be there, so they are winning. Okay, so this time I'll be multiplying. And how am I getting this sense of multiplication? You can see this directly over here. Okay, so who all can be winner? As I have mentioned, b1, b2, b3, and g1, g2, g3, g4. So winners could be like b1, g1, b1, g2, b1, g3, and b1, g4. And similarly I can move like b2, g1, b2, g2, b2, g3, b2, g4, and then for the b3, g1, b3, g2. So overall, how many candidates will you be having then? Would be 12 only. Okay, and that's how we are getting this. Okay, that one of the boy, if I have the candidate who is winning, so among these I can have like any of the girl present. So for one of the candidate I am having like four girl choices, and if there is some other boy, again other four. So that's how we are coming up with this 3 times 4 or 4 times 3. The answer is 12. Okay, the basic idea. Okay, so for the people who are already knowing it, congratulations, but okay, not all the students know this really well, so that's why I have started with this. Okay, so let me just take one more example and then we'll talk about the main stuff. As I have already promised that we'll be starting from scratch, that's why I have to go like this. Okay, completely from the scratch. The next example I can take off is let's say we are having this okay, we are in this, let's suppose A city. Why is it not writing? Yeah, A city. Okay, then I'm having B city. This is like one of the best example I usually take whenever I teach these kind of things. F. Okay, so let's suppose I have to move from A to E. A is a city, E is a city. Okay, and I have to go. And what are the number of there are a number of cities, so there are basically 2 paths. One path goes through these three cities, B, C, D. The other path goes through only one city, that is F. But still, for each of these cities, again, we have multiple paths available. For an example, for A to B, I am having, okay, let's suppose one only, but over here from B to C, I'm having, let's suppose two paths. And from C to D, let's suppose we are having three paths. And again, from D to E, I'm having, let's suppose, two paths. Okay. And if I talk about A to F, let's suppose I'm having something like this. Okay, three paths. And from F to E, something like this. Okay. So basically, I'm talking about four paths. So what are the number of ways I can reach from point A to E? I want to know. Okay, just simple. These are the formulas you have to use. Addition and multiplication, I have already mentioned you. So in how many ways I can reach from A to E? That is the question I'm having. So see over here. From A to B, if I want to reach from A to E, I have two choices. One is via ABCD. The other is via AFE. Okay, so I have two choices. Via this is like ABCD or AFE. These are the two choices I'm having. So in whatever ways I can follow this path, plus in whatever ways I can follow this path, that is going to be my final answer. Okay, because I want to be going with this path ABCDE and this path. I'll be taking only one path. No, so final answer would be in whatever way I can follow ABCDE plus in whatever way I can follow AFE. Okay, that is going to be my final answer. So if I talk about ABCDE, what are the number of ways I can cross it? So see, from A to B I have only one choice. From B to C I have two choices to complete this. From C to D I have three choices. From D to E I have two choices. Because I want to go from A to E, I have to cover A to B, B to C as well, C to D as well, and D to E. So whatever are the number of ways for A to B multiplied by B to C into C to D into D to E is going to be my answer for ABCD, number of paths. And similarly, from A to F would be multiplied by F to E. So what are the number of ways for this? AB, it's 1. For B to C, it's 2. Again, over here, if you see 1 plus 1, this is also again addition rule is taking place. Okay, we are using that only by default. Okay, so it's 2, 3, 2. What is the answer? 2, 3, 6, 2, 12. 12 is the answer over here. And what is the answer for this? 3 into 4. That's again 12. So the final answer would be 12 plus 12. That's what? 24. 24 is the answer. Okay. So that was like basic about addition rule and multiplication rule. Okay. I hope it is clear. We have taken two examples. One was hackathon example. It can be like coding hackathon or whatever kind of project hackathon you would like to take. Okay. And this was like a kind of way you can travel from one city to another city. I hope it is clear. So basic idea I have given you over here. Okay. So now let's talk about the further terms we have. Okay. Let's talk about what are these terms. Okay. So I'll be giving you just brief intro and then we'll be covering each of these. Basically starting from permutation, we won't be going in depth with factorial. It's like simple concept. Okay. So what exactly is factorial? For those who know, amazing guys, you are amazing. If you don't know, I'll be telling you right now. So factorial is just like a notation we are having short for consecutive multiplication up to 1. For an example, if somebody says 6 factorial, what does it mean? It means 6 into 5 into 4 into 3 into 2 into 1. Did I miss something? Yes, 3 I have missed. So 6 into 5 into 4 into 3 into 2 into 1. That's 6 factorial. Similarly, if I say let's say n factorial. So what is going to be that? So if I say n factorial, what is that? That is nothing but n into n minus 1 into n minus 2 into n minus 3 and so on up to 1. So it's like multiplication of consecutive terms starting from n till 1. That's n factorial. Okay. And why do we have that? Yeah, it's like simple thing because many a times we need kind of some notation to simplify something, some values. Okay. And some kind of calculation. So over here we have this kind of notation. Okay, factorial notation. The significance will be seen when we'll be talking about permutation, combination, distribution. Okay, so one important point over here, 0 factorial is 1. Just remember that. Okay, don't make any mistake over there. 0 factorial is 1. Just remember. Okay, so let's move further. Now I'll talk about permutation, important concept. Okay, uh, written in the syllabus as well, permutation and combination. So we're talking about permutation. So just remember this, very important. Permutation means arrangement. What is it? Permutation means arrangement. Arrangement. It's important, very important. Okay. Yeah. So what exactly are we talking about? Whenever there is an arrangement, there is an ordering or order we are talking about. Okay. Always a sense of permutation is there which comes up. Okay. For an example. So let's say if I talk about, these are the cases I have created over here. So let's say I'm talking about that. Okay. I'll not be saying the word permute. I'll be saying the arrangement, because if I say permute, that by default means I'm talking about permutation only. Okay, so over here let's say that we are having, let's suppose I'm having 5 chocolates over here. Okay, 5 chocolates I'm having, all different chocolates from different companies. Okay, with Silk, Kit Kat, Milky Bar, what else we have, like Munch, Perk, other. Okay, you can take any of the 5 examples, any of the 5 different chocolates, and the thing is, in what ways I can consume them, in what ways I can consume them. So simple stuff is there, that okay, I won't be, so over here I'm not talking about that okay, I can stuff my mouth with 2 chocolates or 3 chocolates all together, no, or 5 chocolates all together. I'm just talking about one by one. Okay, so there would be an order which would be followed. For an example, so the first one can be Silk, or second can be Milky Bar, then can be Perk, then Munch can be there, then Kit Kat can be there. So if I have this is for Milky Bar and this is for Munch. So there is an order being followed. Can it change? Yes, there could be like Perk, then Kit Kat. Okay, let me just differentiate it over here. So P, K, S, U, and M, I. Okay, so this could be also one of the order. So yeah, that is the permutation, the arrangement. So what exactly is the number of ways I can do that? So if I talk about, so there are 5 positions I'm talking about. So I'll be consuming one first, then one on the second number, third number, fourth and fifth. So what are the number of ways I can consume? So for the first one I am having 5 choices because I had 5 chocolates, so it's 5. For the second one, again I have like 4 choices because one has been consumed by me. So how many chocolates I was left with? 4 only. Then third one, I have 3 chocolates left. So I had 3 choices because I have consumed 2 out of 5. So that's why I was left with 3. So 3 choices. Over here 2 because 3 have been consumed and 1 at last. So what is this? So I'll be multiplying it. Okay. So either you can write a complete multiplication and then tell me the answer final. Okay. Or the thing is, we can write it as 5 factorial as well. That is also fine. Okay, 5 factorial. So I hope that is correct. Yeah, that's correct. So that is the answer over here. Now the thing is, this is exactly the arrangement over here. Okay, so now I'll be, if I have so if I could tell you though that there was a question that okay, I'm having, let's take another example over here. Okay, if I'm having something like, okay, 10 different things, what would be the answer? The answer is simple, 10 factorial. If I talk about their ordering, 10 different things. Important, this is very important. Things were different. If there are things alike, then the scenario changes. Okay, so if there were 10 different things, then in that case the answer would be 10 factorial. Okay, so if I talk about this, okay, let's suppose only R things needs to be arranged, okay, out of N. Still I'm having different things. Okay, what did I say? R things out of N I need to arrange. So let's suppose I had 5 chocolates, or let's say I had 10 chocolates. Out of those I need to consume 3 only. So there again would be some kind of ordering or sequence that would be coming for sure. and I have 10 different chocolates. Okay, so I have only 3 positions because I will be consuming 3. Why? Because diabetes ho jayega. Okay, so yeah, we have to avoid sugar as well now. So yeah, I'm talking about 3 chocolates right now. So what will we'll be doing over here? So we'll be consuming 3. So what can be the order, or what can be number of ways I can consume? So again, for the first one, I will be having 10 choices. For the second one has been consumed. I'm left with only 9 now. So 9 choices for the second one. 2 chocolates consumed. I'm left with only how many? 8 chocolates now. So for the third one, I had 8 choices. So you just multiply what you get. You get 10 into 9 into 8. So now you are not getting any kind of factorial notation over here. Okay. But if I could have multiplied it with 7 factorial divided by 7 factorial, then it could have been something like 10 factorial by 7 factorial, which I could have write like 10 factorial. I'm not complicating it. I'm just trying to, just relate it with the stuff you already know. Okay. So here comes the formula, which is like NPR. Okay. If you go by the simple mathematics basics, you'll get the answer correct. Okay, 720 will be the answer that you'll be getting easily. If you want to go by the formula, and there are n different things, and if you want to arrange only r things out of that, then NPR is the formula, which is like n factorial upon n minus r factorial. Okay, and if you had out of n all needs to be arranged, as I have already mentioned, we already did it without using the permutation formula, but still it would be NPN. And already it's going to be n factorial by 0 factorial, which is like 0 factorial is 1, you already know. So the answer is coming out to be n factorial again. Okay, so these were the basic 2 cases. This is when we need to arrange everything we are having, and all the things are different, all the items are different, and this is when we need a subset of them. Okay, we need only a few of them, and we need to arrange them. Okay, so there can be other way also, which we will be looking in the next session, basically because I'm not going to create very long session over here. It would be like short sessions. No, I hope that no session goes beyond 30 minutes. Okay, so let's talk about this third case now. So yeah, we are, I guess, yeah, we are presented. So yeah, let me raise this and let me just talk about this thing. Okay, items are alike. If some items are alike, okay, let me just give you an example over here. It can be related to this thing as well. Okay, let's suppose I'm having these 5 letters A, B, C, D, E. Okay, if I talk about in how many ways I can arrange them to create a word, the answer is 5 factorial. There are 5 are different. Okay, and if I say, okay, I only need 3, okay, and I want to create different words from that by using 3 only from these, so we already know 5p3, okay, which is like 5 into 4 into 3. Again, simple stuff. But if I'm having something like this, okay, I'm having A, B, C, D, E. Let's suppose something like this. I'm having 2 identical letters, okay, and something like this can again be there, that okay, if I had 2 silk chocolates, when I took the example of chocolates consumption, okay, eating chocolate, so there also I could have repeated 1, and then I could have asked that what can be the number of ways I can consume them. Okay, so it's like similar to that only, that if not all items I'm talking about, if all the items are same, okay, just let's take a guess. Okay, if all the items are same, in what way I can arrange them? In what way I can arrange them? Simple question. So the answer is going to be 1. Do I need to arrange them? No. Everything is same. I just need to just pick any and then consume or put them in order. It would be remaining same always. Okay. So it is going to be 1. So the thing is, if few are different and few are alike, what would be happening in that case? So I'll be coming up with a formula over here, that how does the exact formula of what we have. The formula, let me just tell you, is kind of n factorial upon p factorial, q factorial, r factorial. And what are p, q, r? So if I say that I'm having kind of n different objects, or n, not all, basically I'm having n objects or n items I'm having. Okay, out of them p are alike, q are alike, and r are alike. Okay, for an example, let's say I'm having 20 chocolates. Out of them 3 are silk, 4 are Kit Kat, and 5 are Munch. Rest all are different. The thing that where we have a repetition or the identical chocolates are silk, Kit Kat, and whatever I talked about, like Munch. Okay, so we have this kind of example. In that case, the number of ways of ordering them, arranging them is going to be n factorial by p factorial by q into q factorial into r factorial. Okay, so the answer for this one would be in that case 6 factorial by 2 factorial. I hope there are what, like 6 letters in total. So yeah, 6 letters in total, and whatever are identical will be dividing by their factorial. Now, how does it come? So I'll give you a brief idea about that, because we'll be using that idea repetitively, and the questions were being asked in the exam as well. Okay, so let's suppose that these two C1s were not identical. These were different. Okay, and let me just take an example over here. A, C1, B, D, C2, and E. And let me write another one. A, C2, B, D, C1, and A. Now just tell me and think about this. That okay, when these C1 and C2, basically these are different, these two orderings, these two arrangements are looking different. Okay, like I can write C1, C2. You can see these are different arrangement. That's because I have labeled them differently now. But if they would have been same, then it would have been there would have been a double counting, a kind of redundancy, that we are having some extra arrangement which are like identical to the existing one. That is, these are nothing but like this only. Both are the example of this only if C are identical. Yes or no? So I'm having a kind of double counting over here. So what would be the total number of ways I could arrange them? The answer is quite simple. Let's say I don't know that what would be the number of ways I could arrange them. Let's suppose the answer would have been X. What did I say? I don't know what would be the number of ways I could have these arrangement, but let the answer be X. And now I know among them, if these two C which are present, if they would have been different, then I could have arranged them among themselves. What did I say? If they would have been different, I could have arranged them among themselves. And if they would have been different, in total, how many arrangements could I have? It was 6 factorial. 6 factorial. So if the total arrangements with identical ones, what did I say? Let me just repeat it a bit. If these were identical over here, okay, I don't know the answer for that. Okay, I don't know. Let's suppose the answer is X. Now, if they were different, I could mark like this. Okay, and something like this. Let's suppose C1, D, E, and then C2. A, B, C2, D, E, C1. I'm just giving you an example. Both are different if C1 and C2 are different. Okay, but if C's are same, then this is going to be one count only. We'll be counting them once. So what did I say? I don't know in how many ways I can arrange them, and if I just multiply with the ways the identical objects could be arranged among themselves to create the redundant ones which we needed, what will I be getting? I'll be getting the answer which would have been there if they all have been different, which was 6 factorial. So it must be equal to 6 factorial, and that's how we can get this simple idea as well. Okay, and that's how we can get this formula as well, that if we could have arranged those identical elements among themselves, for all the identical elements I'm talking about, if there are p identical elements, just arrange them. Okay, let's suppose the final answer I had for the identical elements when we had it, okay, was X. So if I could have arranged p elements which were there alike, I could have multiplied, arranged them among themselves, q among themselves, r among themselves. So I could have be getting n factorial when they all were different. So that's how we get that kind of formula. Okay. So I hope both the points are clear, either with this way or with the direct formula way. Okay. So now let's just talk about the next point we are having, which is like the permutation with the repetition. Okay. Let me just talk about that. Permutation with repetition. Okay. What exactly is that? So it's like I'm having now number of options. I'm having number of options. It's like if I say that I'm having these letters F, E, F, G, yeah, let's say up to G. So I'm having infinite A's, infinite B's, infinite C's, infinite D's, infinite E, infinite F, infinite G. Okay, so something like this. And I have to create a word of 3 letters, or it can be like go up to a like extent like 100 or like any length, because I'm having for each type, for each letter type, I'm having infinite letters. Okay, so we can consider it to any length. Okay, so what would be the number of ways I can create that word, or what could be the arrangements possible if I want to create only 3-letter word? What are the total number of ways I can create it? So see, 1, 2, 3, 4, 5, 6, 7. I'm having 7 letters, and any letter can come over here. This is like simple as we have done over here, like for this and this. Okay, though we were not repeating anything, but for the first letter, for the first position, it's like same. Okay, what about second? So whatever I have used over here, I can use that also over here. Repetition is allowed. I can use A anytime, I can use B anytime, I can use C anytime. It is like that. Okay, so in that way I have to tell what are the number of words I can create. So again, I have 7 ways to fill it up, 7 ways to fill it up. So always remember, when we have n different elements and kind of repetition is allowed, we can repeat the stuff. Okay, so it's like you can be asked that, okay, we have n different kind of chocolates we are having. Okay, and then we are having like enough of it, we can repeat any chocolate. Okay, then if I want to consume 5, if I want to consume 5 chocolates, what can be the number of ways I can do that? So it would be like simply n to the power 5. It's not visible properly, so it is going to be n to the power 5. How? See, because for each of the position, if I want to consume 5 chocolates, for each of the position, I'll be having n candidates, n chocolates. Okay, and I can repeat the chocolate because I can, as I mentioned it, repetition is allowed, and I have enough of chocolates for the repetition. Okay, so whenever we have repetition, the sense is of n to the power r. For this one, we had the formula like n factorial by p factorial, q factorial, r factorial. For this one, it was npr. For it was n factorial. I hope the point is clear with respect to the permutation. Okay, so I can extend this session further as well, but the thing is, I guess the session would be getting too long, and I don't want that. I don't want to make it a bit boring. So yeah, we'll see you guys in the next video, and we'll be creating a proper playlist for it. Need not worry. So next one would be the combination. I'll be talking about what exactly is the combination, and then further I'll be talking about distribution. Okay, so we'll see all that in the next video. Okay, so now if you are somebody like who is who wants to join us, so right now this is the WhatsApp channel we are having. Joining fees is not there. It's like simply for the updates, for the videos, and for the any kind of update with respect to the gate. Okay, whatever we are coming up with, so you can join our WhatsApp channel over here. And if you want the notes, the PDFs, okay, the PPT, and you would like to discuss anything, you can join our Telegram group. Okay, so that was all about it, guys. So see you guys in the next session. Till then, take care. Bye bye. Thank you.